The night of February 24, 1944, hung dark and heavy over Anzio, Italy. Two complete SCR-584 systems arrived in the chaos and were urgently positioned, buried deep into the sandy ground until their trailers disappeared from view, all accomplished under the cover of darkness. The following evening brought a new threat. 12 German bombers pushed into the airspace above the beachhead, confident in their numbers and experience. Within moments, that confidence evaporated. The 90mm guns, guided by the SCR-584 radar, tore through the night sky. 7 bombers fell burning to the earth, 7 out of 12. The numbers alone seemed impossible. They defied everything military strategists understood about air defense. Before this moment in history, even under ideal daylight conditions with perfect visibility, anti-aircraft gunners needed to fire roughly 2,500 shells to destroy a single aircraft. Tonight, in complete darkness, the mathematics had inverted. A 58% kill rate, unprecedented. The surviving German pilots radioed back descriptions that shook their commanders. Black explosions that bloomed exactly where they would be seconds later. Flak bursts that seemed to anticipate every turn, every dive, every evasive maneuver they attempted. Anti-aircraft fire that possessed an almost supernatural accuracy, as though the guns could read their intentions before they executed them. This wasn't luck or exceptional marksmanship. This was something entirely new. The SCR-584 was an automatic tracking microwave radar system, a piece of technology that would fundamentally change how nations defended against air attack. Throughout the remainder of the war, German intelligence would struggle to understand what had happened over Anzio that night. They would never fully grasp the revolutionary system now deployed against them. The seeds of this technological breakthrough had been planted years earlier. Back in 1940, British scientists made a decision that would reshape the war. They shared their cavity magnetron with the Americans through a classified scientific exchange. This single 10-centimeter device, so carefully guarded and so powerful, became the foundation for everything that followed. While German radar development continued down a conventional path, relying on older meter-wave technology that had served them well enough until now, American engineers at MIT's Radiation Laboratory were building something radically different. They were constructing the future of warfare, one component at a time. The SCR-584 could detect an aircraft 40 miles away. It could measure range with an accuracy of 75 feet. It operated on microwave frequencies that German detection equipment simply could not perceive. The system pulsed 300 kilowatts of power at frequencies between 2007 and 2009 megahertz, with wavelengths measuring just 10 to 11 centimeters. It sent out pulses lasting 0.8 microseconds, repeating 1,707 times every second. German radar warning receivers, designed to detect British radars operating at far lower frequencies, between 200 and 600 megahertz, were completely blind to these emissions. The technological gap extended far deeper than mere frequency differences. The SCR-584 employed automatic tracking through conical scanning, a technique that rotated the radar beam in a cone-shaped pattern, allowing it to lock onto moving targets and follow them without any human intervention required. When paired with the M9 gun director, an analog computer containing 160 vacuum tubes, the system became something extraordinary. It calculated firing solutions 30 times every second. Wind speed, air density, target velocity, gravitational drop, all of it factored in instantly. The guns positioned at Anzio represented a watershed moment in the history of anti-aircraft defense. Air attacks ceased for an entire week. Then a single German plane appeared, probing the defenses, testing their response. It was destroyed immediately. By that week's end, 10 more systems had been installed around the beachhead. The air threat to Anzio effectively ceased. German bomber crews who had successfully struck Allied positions for years suddenly confronted something they had never encountered. The system's power came from its complete automation. Once the SCR-584's operator acquired a target and engaged automatic tracking, the radar locked onto that aircraft and followed it through every maneuver, every evasive action, no matter how desperate. The tracking data flowed directly into the M9 director, which computed the exact position where shell and aircraft would meet. The 90mm guns slaved to the director moved in perfect synchronization, their barrels swinging to invisible coordinates defined by mathematics. German crews reported phenomena they could not explain. Flak bursts that seemed to predict their evasive maneuvers. When they dove, shells exploded where they would be at the dive's bottom. When they turned, explosions appeared along their future flight path. This was not the barrage fire they had known from years of combat. This was precision firing executed by machines that calculated faster than any human mind could react. While German scientists hand-built radar sets in small workshops, each one slightly different from the others, each requiring specialized technicians and countless hours, American industry approached the problem differently. Chrysler Corporation applied assembly line techniques developed for automobiles to radar production. Craft manufacturing became an industrial process. Approximately 1,700 SCR-584 systems were produced. By August 31, 1943, 610 had shipped to operational units. The Dodge Division delivered system number 1470 on January 28, 1944. An additional 628 sets went to the Marine Corps and Coastal Defense, with more reserved for spare parts, bringing the total to over 2,000 units. A single American company had produced more radar systems than Germany manufactured throughout the entire war. The contrast revealed fundamental differences in how the two nations approached industrial war. German radar sets demanded highly skilled assembly workers. Each unit possessed unique characteristics. The SCR-584 used interchangeable parts and modular construction. Soldiers with basic training could perform field repairs. Where Germany built dozens, America built thousands. When the invasion came on June 6, 1944, 39 of these systems crossed the Channel aboard the invasion fleet. They had been specially waterproofed for the amphibious assault, creating an unprecedented defensive umbrella over history's largest invasion armada. German attacks on the beaches were systematically defeated by fire that seemed to anticipate their every move. Oberst Joseph Pips Preiler, one of only 2 Luftwaffe pilots to attack the invasion beaches on that day, survived to provide testimony after the war. In his debriefing, he described anti-aircraft fire unlike anything encountered in 5 years of combat. Not barrage patterns that forced pilots to weave through walls of explosions. These were aimed shots, precise bursts that forced constant evasive maneuvering and made accurate attacks impossible. The Luftwaffe's failure at Normandy stemmed not from lack of courage or pilot skill. German pilots had flown into a technological trap they did not understand. The few who returned reported the same phenomenon witnessed at Anzio, anti-aircraft fire that seemed to read their minds, predicting maneuvers before they were executed. The defense against Hitler's V-1 flying bombs provided the clearest demonstration of the SCR-584's revolutionary capabilities. These pilotless weapons traveled at 400 miles per hour in straight lines at constant altitude. By all logic, they should have been ideal targets. Yet their speed made them nearly impossible to hit using conventional aiming methods. Shot after shot missed its mark. Barrage fire proved ineffective. 20 SCR-584 systems were assigned to England's Channel coast to reduce the number of V-1s reaching London. 80 guns operating with new proximity-fused shells began destroying the flying bombs at a rate that seemed almost miraculous. On one Sunday, 97 out of 101 V-1s were shot from the sky. The statistics documented a genuine revolution in anti-aircraft effectiveness. In the first week these guns operated on the coast, they destroyed 17% of all flying bombs entering the defensive gun belt. This figure rose to 60% by August 23rd. By the final week of August, the rate climbed to 74%. On one extraordinary day, 82% were destroyed. The improvement in ammunition efficiency was staggering. Where conventional anti-aircraft fire required approximately 2,500 shells per kill, the SCR-584 guided guns achieved 1 kill for every 100 shells fired. A 25-fold improvement. German observers on the French coast watched in disbelief as V-1s exploded after short, precise bursts of 3 or 4 shells. Such accuracy contradicted everything they understood about anti-aircraft warfare. The German failure to recognize the SCR-584 threat originated in a fundamental scientific miscalculation. In January 1943, German radar experts, led by Professor Abraham E. Saw, had convinced the high command of something that seemed theoretically sound. Microwave radar, they argued, was physically impossible. At such high frequencies, insufficient energy would return to receivers to prove useful for detection. Based on this flawed theoretical analysis, Germany terminated all microwave radar research. Development stopped, resources redirected. Then in February 1943, German forces captured a British H-2S radar. When they examined it, they discovered it operated on centimeter wavelengths. The revelation came too late. Germany had already fallen years behind in microwave technology, a gap that could not be closed during wartime. German intelligence consistently misinterpreted mounting evidence of Allied radar superiority. Pilot reports describing impossible anti-aircraft accuracy were dismissed as improved training, better optical sights, or simply more guns deployed. The possibility that Americans had achieved automatic radar tracking at microwave frequencies remained beyond German conception until late in 1944. Throughout 1944, Luftwaffe electronic warfare units operated with equipment designed for an earlier war. The FUG-227 Flensburg detector searched for frequencies between 170 and 220 MHz. The EFUG 350 Naxos covered 2,500 to 3,650 MHz, closer to the SCR-584's range, but still unable to reliably detect its emissions. More fundamentally, German radar detectors were designed to identify search radars that swept beams across aircraft briefly. The SCR-584's conical scanning maintained continuous lock on single targets, producing emission patterns that German equipment did not recognize as threatening. Luftwaffe crews flew into radar-guided death traps while their warning receivers remained silent. They had no warning, no defense, no comprehension of what was happening until shells arrived exactly where they would be. The system Chrysler Corporation produced was designated the SCR-584, a complete air defense package that integrated multiple revolutionary components. A heavy anti-aircraft battery of 90mm guns, a British-invented IFF identification unit, a power source, the M9 gun director. Each component represented American engineering mastery. The cavity magnetron alone generated 300 kilowatts of microwave power, more than entire German radar installations produced. The servo mechanisms for automatic tracking achieved precision that German industry could not replicate. The M9 director performed ballistic calculations that would have required entire teams of human computers working in constant coordination. The integration of these technologies into a single weapon system represented a conceptual leap that German military thinking had not achieved. Approximately 1,500 of these complete systems were deployed in Europe and the Pacific beginning in early 1944. Each could track aircraft traveling at 600 miles per hour, faster than any operational aircraft of the era, providing future-proofing that proved valuable when German jets finally appeared. By mid-1944, the Luftwaffe faced a crisis of unsustainable losses. Galland reported that Luftflotte Reich had lost 38% of its fighter pilots in April 1944. Luftflotte III had lost 24%. In total, Germany lost 489 pilots, 100 of them officers, while training centers managed to forward only 396 new pilots, just 62 of them officers. These losses were not solely from air combat between fighters. Increasingly, experienced pilots fell to anti-aircraft fire, exhibiting impossible accuracy. Ground attack aircraft, essential to German tactical doctrine, became particularly vulnerable when operating within the SCR-584's optimal tracking envelope. Adolf Galland, in his post-war memoir, would write about this period with the language of desperation. By 1944, approaching Allied positions meant entering zones where death was mathematically calculated. The guns did not aim where we were, but where we would be. There was no tactic against it, no countermeasure, only luck. Galland understood what his pilots had discovered through bitter experience. They faced not an enemy they could outmaneuver or outfly, but a system operating on principles they could not counter. In December 1944, during the Ardennes offensive, German forces finally captured a damaged but largely intact SCR-584 near St. Vith. Dr. Hans Plendel, Germany's leading radar expert, led the technical examination. His report to the High Command devastated any remaining hope. The Americans have achieved automatic tracking with accuracy we believed impossible. They operate on wavelengths we cannot detect or jam with existing equipment. Most significantly, they mass-produce these systems while we struggle to build laboratory prototypes. We are not months behind, we are years behind with no possibility of catching up. The captured system revealed innovations that German science had deemed theoretically impossible. Automatic tracking that maintained lock despite target maneuvers. Electronic computation of three-dimensional firing solutions. Seamless integration of radar, computer, and weapons in a single cohesive system. But this knowledge arrived too late to develop countermeasures or equivalent systems. The technological helplessness experienced by Luftwaffe pilots contributed to an extraordinary event in January 1945. Germany's leading fighter aces, the nation's most decorated warriors, initiated what became known as the Fighter Pilots' Revolt. Leading pilots, including Adolf Galland, Johannes Steinhoff, and Gunther Lutzow, confronted Hermann Göring directly about the impossibility of their situation. Johannes Steinhoff, who had achieved 176 confirmed victories, looked directly at Göring and spoke with the clarity of someone who had exhausted all alternatives. "We are not fighting enemy pilots anymore. We are fighting mathematics calculated by machines. Individual skill has become irrelevant against automation. You blame us for lacking courage, but courage cannot defeat technology we do not possess." These were not defeated men. These were Germany's most celebrated combat veterans. Their recognition that traditional military virtues had become obsolete against automated weapons represented a profound psychological breaking point. Courage, skill, experience, tactical brilliance, none of it mattered anymore. The war had entered a new realm. Göring's response demonstrated leadership's inability to accept technological reality. He relieved Galland of command and threatened courts-martial. His words could not change the facts of combat. Even the revolutionary Me-262 jet fighter provided no escape from SCR-584 directed fire. The jet's speed of 540 miles per hour, which made them nearly untouchable by Allied fighters, meant nothing to radar systems designed to track targets traveling at 600 miles per hour. Oberstleutnant Heinsberg, one of Germany's most successful jet pilots, reflected after the war on this technological trap. "We believed our speed would protect us from flak. Instead, we discovered the American guns tracked us perfectly. The shells arrived exactly where we would be. Speed could not save them. Neither could any tactic German pilots possessed. Faster jets meant less time to escape. We watched several of our aircraft fall from the sky, victims of anti-aircraft fire that seemed impossibly accurate. The SCR-584 demonstrated something remarkable: American engineering that anticipated threats the Germans never saw coming. Built according to specifications that exceeded anything flying in 1942, it remained devastatingly effective against aircraft that wouldn't take to the skies until late 1944. The production numbers told a story of industrial dominance that made German defeat inevitable, no matter how clever their tactics became. One American corporation alone, Chrysler, showed what was possible. Over 2,000 units, that was Chrysler's confirmed output. The minimum total reached beyond 1,700. General Electric and Westinghouse added their own contributions to the total. The price per unit dropped dramatically, from $50,000 down to below $10,000. When production hit its peak, factories rolled out more than 50 units each month. The Germans produced their VIRT Spur radar. Their numbers barely reached 1,500 across the entire war. When you added every German radar type together, the total came to roughly 4,000 units. Each one was essentially assembled by hand. German manufacturers never achieved significant cost reductions. Their production capacity remained strangled throughout the conflict. This gap revealed something deeper about American industrial thinking. The SCR-584 worked with drafted civilians who received just 6 weeks of training. German radar systems demanded engineers and technicians with months of specialized study. The advantages went beyond raw specifications. The SCR-584 proved superior in practical ways that multiplied its destructive power, rapid deployment and movement. A unit could be operational within 30 minutes of arrival, while German systems required hours to become functional. This mobility became essential during Italy's unpredictable campaign, where the SCR-584 provided instant air defense for advancing troops. It operated continuously through rain, snow and fog that rendered optical targeting useless. German systems performed worse when weather turned bad. The modular design allowed operators to swap out damaged components. German equipment demanded specialized technicians for minor maintenance. Operating the SCR-584 required just 3 people. The German Verti Spur demanded 8. After the war, Field Marshal Albert Kesselring reflected on what he'd witnessed. American radar made our air support impossible by early 1944. The Wehrmacht, which had invented combined arms warfare, discovered itself fighting blind while Allies controlled everything from above. The campaign against flying bombs provided clear evidence of this technological shift. The first week brought a 17% interception rate using traditional methods. By week 4, 60% of targets were destroyed. Week 8 showed 74% success. The best single day achieved 82%. Ammunition consumption dropped dramatically through improved efficiency. For the first time in military history, defensive guns became consistently superior to attacking aircraft. The V-1 flew predictable routes that should have made it vulnerable, yet its 400-mile-per-hour velocity rendered conventional anti-aircraft fire nearly worthless. The SCR-584 changed everything about that equation. German electronic warfare had devastated British radar earlier in the war, but it couldn't touch the SCR-584. Luftwaffe jamming equipment operating on meter wavelengths proved useless against microwave systems. German chaff cut to meter wavelengths wouldn't work either. The failure ran deeper than equipment. German doctrine assumed enemies used similar technology. The idea that Americans operated on completely different physical principles never occurred to them until captured hardware revealed the truth. By then, Germany lacked both resources and time to develop new solutions. The SCR-584 did more than destroy aircraft. By making German reconnaissance impossible, it blinded Wehrmacht intelligence operations. German commanders couldn't observe Allied preparations, track movement patterns, or discover vulnerabilities. This intelligence darkness contributed directly to German strategic failures between 1944 and 1945. General Hasso von Manteuffel, commanding 5th Panzer Army during the Ardennes offensive, later explained the situation. "We attacked without sight. Our reconnaissance aircraft couldn't survive over Allied territory. We had no knowledge of enemy reserves or troop positions. Without that element of surprise, our plan collapsed." The Luftwaffe experience with SCR-584 cut deeper than fear. Death delivered by machines eliminated the human element from combat. Pilots who trained for years, survived countless missions, and earned their nation's highest decorations discovered their experience meant nothing. Survivors described the psychological devastation. Erich Hartmann, who finished the war with over 220 confirmed victories, captured it perfectly. Fighting other pilots was war in the traditional sense. Skill tested against skill, courage matched against courage. But radar-directed guns weren't warfare at all. They were execution by formula, death calculated rather than earned. There was no honor in falling to a machine's mathematics. This removal of human agency from combat shattered morale far more than simple death ever could. Luftwaffe pilots had prepared themselves for mortality. That was part of the warriors' acceptance. What they couldn't accept was becoming irrelevant. Their years of training, their experience accumulated through survival, their talent reduced to meaningless numbers in an equation beyond their control. When Germany surrendered, Allied intelligence brought captured Luftwaffe officers to examine the SCR-584. Their reactions varied from awe to grim acknowledgement. Many felt almost relieved to finally comprehend their invisible enemy. Wilhelm Runge, who had worked developing German radar, admitted decades later, "We rejected every report that contradicted what we believed about American capabilities. We invented complicated explanations for their impossible accuracy rather than accept the simple answer. They had better technology than us. That refusal to see cost thousands of lives." The Wehrmacht's deeper problem was cultural blindness. The German military, which had revolutionized warfare in the 1930s, couldn't imagine American engineers surpassing German science. This denial persisted even as proof accumulated throughout 1944. After the war, the basic principles informed the AN/MPQ-12 and AN/MPM-38 systems, eventually leading to the MGM-5 Corporal missile platform. Automatic tracking, computer-aided prediction, and integrated systems all descended from SCR 584 concepts. Every modern air defense system traces its lineage backward to this machine. It proved that effective defense required eliminating human reaction delays from the engagement sequence. This lesson, written in Luftwaffe destruction, shaped military development through the Cold War and beyond. Complete statistics disappeared in wartime record loss, but existing evidence shows devastating results. Minimum 1,700 units produced, with Chrysler documenting over 2,100. Monthly output exceeded 50 units at peak capacity. On its first night, it destroyed 7 of 12 bombers, a 58% success rate. Against flying bombs, it reached 82% interception. Ammunition efficiency improved 25 times over. D-Day landings had 39 units providing complete air defense. Detection range of 40 miles doubled German capability. Accuracy reached 75 feet, compared to German measurements of 500 feet or worse. Tracking remained completely automatic, where German systems required manual operation. Deployment took 30 minutes against more than 2 hours for German equipment. The German encounter with the SCR 584 teaches lasting lessons about technological surprise. Believing themselves superior, trapped by assumptions, unable to imagine American innovation, German leadership sent air crews against threats they couldn't comprehend or counter. General Paul Deichmann reflected on institutional failure. "We believed what we wanted to believe. Every contradictory fact got explained away. We couldn't accept that American engineers had accomplished what our scientists declared impossible. When reality finally forced itself upon us, the Luftwaffe as an effective fighting force no longer existed. The core problem wasn't intelligence collection, but intelligence interpretation." German observers reported American anti-aircraft effectiveness accurately. Command dismissed these reports because they contradicted what leadership believed about American abilities. This mental blindness proved more damaging than any security leak could have managed. The SCR 584 embodied American industrial philosophy, mass production combined with standardization and simplification. American engineers designed for reliable mass manufacturing rather than perfect individual units. This approach, born from automobile manufacturing, proved superior to German craft production for military purposes. Operational thinking showed the same contrast. German military culture valued expertise and specialization. American design philosophy emphasized simplification and automation. The SCR 584 succeeded precisely because it removed human expertise from the equation. Skill became unnecessary. This democratization of sophisticated technology proved decisive in total war. The SCR 584 ended aerial combat as a contest between skilled opponents. It ushered in the age of automated warfare continuing today. For the Luftwaffe, this transformation arrived as incomprehensible shock. They entered the war as aerial warriors and ended it victims of mathematical functions. Johannes Steinhoff, reflecting decades afterward, perhaps understood it best. The SCR 584 didn't merely shoot down our planes. It shot down everything we believed about warfare itself. We thought war meant courage, skill, and determination. The Americans showed us it meant technology, production capacity, and automation. We were superb warriors, destroyed by superior machines. The SCR 584 represents one of World War II's most significant weapons, not primarily for aircraft destroyed, but for what it symbolized: the absolute triumph of technological systems over traditional military virtue. the Luftwaffe faced an enemy incapable of missing, having eliminated human error from the firing process. German pilots never truly grasped what they faced because leadership refused accepting its reality. Reports of impossible accuracy were dismissed as exaggeration. Evidence of automatic targeting got ignored as impossible. Only when German scientists examined captured equipment did understanding arrive. By then, the Luftwaffe had already been reduced to helplessness. The Germans never acknowledged that American radar had crippled the Luftwaffe because such acknowledgement would have demanded admitting fundamental inferiority in science, industry, and military capability. That psychological wall remained insurmountable until defeat forced recognition. For the aircrews who encountered it, the SCR-584 was death delivered by machines, calculated with mathematical certainty, immune to human bravery or experience. They flew into killing zones where their fate had been predetermined by circuits and calculations. The era of the warrior pilot ended above European skies, destroyed by American radar that detected invisibly, processed instantly, and eliminated automatically. The SCR-584's influence extended far beyond those wartime years. It established how modern air defense systems should function and proved that automated kill chains decide technological warfare. The Luftwaffe learned this through destruction. Aircraft lost one after another, computed and destroyed by systems incapable of fatigue, incapable of error, and incapable of mercy. The Germans finally understood. When understanding came too late, they hadn't battled American gunners, but American mathematics. Radar systems had transformed the sky into a zone where death was computed. Their courage and skill and hard-earned experience became irrelevant factors in equations they couldn't see, couldn't disrupt, and couldn't survive. That awful recognition marked warfare's transformation, from contests won by the brave to contests won by the technologically superior.